Hello, and thank you for watching our presentation. We are Team Equilibrium, and this is our hybrid pressure cooker project. Our project scope focused mainly on developing countries where open flame conventional cooking methods continue to have negative health and environmental consequences. Mongolia and Kazakhstan were chosen as target countries for a project due to their pollution levels and their traditional cuisine being suitable to be cooked inside a pressure cooker. Specifically, our hybrid pressure cooker takes advantage of readily available solid fuel sources such as coal and wood, and also implements electric resistance heating.
Our system requirements were designed around the idea that we wanted to build a pressure cooker that was able to be competitive or better than current models on the market, but also was able to use fuel sources that were available in our targeted countries. In pursuit of that goal, we had to build a pressure cooker that could have an internal pressure of at least 12 psi to have a higher efficiency of cook rate, and also had to be able to reach that pressure in under 30 minutes for our 9-liter part size.
Our mission scenario diagram runs through how the pressure cooker is supposed to be used step by step so that it's very simple for the user. First, we just connect the pressure cooker to its power supply and add the coal to the hopper. Then we fill it with water. Then we push the start button or flip the switch, whichever it is, and it begins heating up. We put the food inside, we seal the lid, allow it to pressurize, and after enough time has passed for your specific recipe, you can depressurize it and unseal the lid.
Throughout the project, prototypes were crucial in order to understand exactly which direction we needed to take with our design. The three main things we learned from our prototypes were the end user experience. How is someone going to interact with the pressure cooker? We learned appropriate dimensions for the cooker, and we also learned of where critical design elements needed to be placed. Elements such as a solid fuel hopper, electric resistance heaters, and for example, where the pressure cooker itself needed to be.
For design and development, we took the prototypes that we had and we actually performed some analysis on it to make sure that it could meet up with the 15 psi demand on the inside of the cooker. So up top is the complete assembly, when it's going to be used, how it's going to look like when it's going to be used. And figure 6 shows a stress FEA across the cooking pot with 15 psi pressure on the inside. Figure 7 shows an actual temperature contour of the water inside to see how hot the water will be on specific spots of the pressure cooker. And all of these analyses helped us prove that it's going to be a very safe and effective way of cooking food.
Now, in the future, we plan to finalize the design after extensive testing in the following categories: product effectiveness, thermal testing, customer satisfaction, and durability. Once all criteria is met, then we will have a final design that is ready for manufacture. Now, this concludes the end of our poster presentation, but before we say goodbye, we would like to appreciate Dr. Garganis and Dr. Zupan for guiding us through this project.